Welcome to English 1 at the University of Crete. I'm Noni Rizopoulou, and in this video we'll take a look at operating systems, the unseen layer that makes your computer work. Every time you open an app, save a file, or print something, there's a system making sure that everything runs smoothly, that resources are shared fairly, and that nothing crashes. An operating system, OS, is a collection of programs that manage the interaction between the user and computer hardware. The main goal is to control and coordinate the operation of the computer, ensuring that hardware and software work together smoothly. Some notable operating systems include DOS, Disk Operating System, was released by IBM for personal computers, and it was one of the earliest widely used OSs. Unix was developed by Bell Laboratories for mini-computers and is highly portable as it was written in the C programming language. It was later adapted to run on personal computers. Linux is an open-source OS created by Finnish programmer Linus Torvalds, based on Unix. Originally aimed at enthusiasts, it is now widely used in commercial platforms, servers, and desktops. Batch processing is a method where multiple jobs are collected into a single batch and executed without further user interaction. In the early days of computing, during the 1940s and 1950s, computers were massive machines occupying entire rooms. Preparing the equipment carefully before execution was crucial. Programs were submitted using punched cards, which were placed in card readers. Switches on the computer were manually set for the program. After execution, the punched cards were removed, retrieved, and prepared for the next program. Because these computers were shared resources, multiple users would reserve time slots using special sheets. The programmer submitted the program along with all necessary data and instructions. The operator loaded the material into the machine's mass storage, ran the program, and returned the results to the programmer. Batch processing allowed early computers to maximize efficiency despite their complexity and manual operation. Modern operating systems use techniques like multiprogramming, time sharing, and interrupts to improve efficiency and responsiveness. Multiprogramming is a technique that allows the CPU to execute multiple independent programs in an interleaved manner. When one program is waiting for I/O or other operations, the CPU can work on another program. In time sharing, a computing resource is shared concurrently among multiple users. Time is divided into small slices, and each job runs for only one slice at a time. An interrupt is a signal sent by a program or device that requires immediate attention. The processor pauses the current task, addresses the interrupt, and then resumes normal execution. Operating systems can be classified based on their purpose and environment. In distributed systems, a job can be shared across multiple computers. Parts of a program may run on one machine while other parts run on another, as long as the computers are connected via network. This allows for scalability, load balancing, and resource sharing. Real-time operating systems are used when timely responsiveness is critical. The operating system gives priority to real-time operations and attempts to handle requests immediately. RTOSs are common in applications like medical devices, industrial controllers, and avionics. Embedded systems are specialized OSs found in cars, airplanes, thermostats, and everyday devices. They supervise program execution on microprocessors. Embedded systems are designed to work with limited resources and are often compact, efficient, and highly reliable. Virtual memory is a technique that allows a computer to run programs larger than the physical main memory by using a portion of disk storage as an extension. Some segments of a program may not be immediately needed for processing. Instead of keeping them in main memory, they are stored on disk. The operating system and memory management software ensure that the required segments are loaded into main memory only when needed. This process is based on a programming method called overlaying, where overlays of a program are loaded into memory just in time for execution. By doing this, virtual memory extends the storage capacity of physical memory and creates the illusion of a much larger main memory for programs to use. The state diagram helps us understand the relationships between a program, a job, and a process. A program becomes a job when the operating system selects it and brings it to the hold state. In this state, it waits until memory becomes available. Once memory is ready, the job moves to the ready state and becomes a process. It waits in memory until the CPU can execute it, at which point it enters the running state. From the running state, one of three transitions can occur. The process may move to the waiting state if it requires I/O operations. If the process has used up its allocated time slice, it returns to the ready state. The process may terminate once execution is complete. This cycle of transitions allows the CPU and operating system to manage multiple processes efficiently, ensuring fair access to resources and smooth execution. Deadlock is a common issue in concurrent systems where multiple processes share resources and require control access. It occurs when a process is waiting for a resource held by another process, while that process is in turn waiting for another resource. This creates a circular wait, resulting in a state where no process can make progress. In communication systems, deadlocks may also occur due to lost or corrupted signals, not just resource competition. In essence, a deadlock is a system standstill where processes are blocked indefinitely unless special handling, like resource arbitration, is implemented. Starvation occurs when a process is perpetually denied the resources it needs to complete its work. Causes of starvation include resource leaks, where a program fails to release resources it has acquired, or scheduling errors that prevent certain processes from getting CPU time. A classic example is the dining philosopher's problem introduced by Esther W. Dijkstra. 5 philosophers sit around a table, each needing 2 chopsticks to eat. Chopsticks are shared with neighbors, so a philosopher may wait indefinitely if the required chopsticks are not simultaneously available. In this scenario, a philosopher may starve even though other philosophers continue eating. Starvation illustrates the importance of fair resource allocation in operating systems to ensure no process is indefinitely blocked. The user interface is the space where humans and computers communicate. It is a program within the operating system that accepts requests from users and interprets them for the rest of the system. There are two main types of user interfaces. Command line interface, CLI. The user types text commands directly to the OS. And graphical user interface, GUI. The user interacts with the OS through graphical icons, windows, and visual indicators. In short, the user interface determines how users interact with a computer, influencing ease of use, efficiency, and accessibility.